Hi, I'm Mike Balzer, and I was asked about 2 or 3 weeks ago to moderate this panel. We're going to talk about some of the myths and truths about 3D printing. And we've got a few experts here, which I'll introduce in a little bit. My background is that I run in San Luis Obispo, California, which is kind of in between LA and San Francisco, a kind of a 3D print, design, scan, and educate shop on 3D, doing it for the last year and a half. And I also started a podcast about a year and a half ago called All Things 3D. And I've had an opportunity to talk to a lot of people, including John up front here, and quite a few people around the world. So it's a really interesting, exciting adventure that I've been through. And then lately I've been able to use some of my skills, in the case of my wife who had a brain tumor. And so you notice I kind of keep her with me all the time, a little closer than most people. And I'm also working right now with the Shriners Burn Center in order to create a scanning device. So I think there's a lot of uses for it. Hopefully we'll get through a lot of these things, both from the myth and truth side perspective. But before we get started, how many people know about 3D printing and what it is? I'm going to try and make this interactive. And one of the things as we go through the truth and myths is I would like you to say truth or myth, and then we'll kind of see if that's true or not. So kind of a 3D printing 101 is what we're going to go through really quick. And if you say, I know enough about this, please move faster, just tell me so. But essentially, a 3D printer, if you remember back, I guess I'm dating myself here, there was something called a 2D plotter with pens. And you essentially gave it a command to touch the paper and draw, and gave it a command to lift the paper and draw, and then you moved the XY coordinate to let it draw. And these were called 2D plotters. So somebody took that idea and said, well, what if we added a Z, depth or information to it on a bed, and that became a 3D printer. So the other thing is, well, how do you make a 3D object? So if you notice down on the bottom there, I have a glue gun. So if you can take a glue gun and put that in your head and you push it at a finite amount of period, if you look next to it, that's a nozzle. So the nozzle is actually thinner than a glue gun. And you put melted plastic through that. As it creates the layers, it hardens, and then the layer is put on top of it until you eventually have a tangible product. So here on the left-hand side, if you can see it, is an illustration. You have your X, which causes the move left to right, and then you have a Y that moves back and forth, and then the Z, which moves it up and down. And then the whole idea is to get an octopus, maybe not, but some type of tangible object when you're finished with it. And so that's what we're going to kind of talk about today. So any other questions about 101 before we move on? Didn't think so. Okay, so let's kind of go into our panelists. I'm going to start on the left-hand side, and we're going to bring up Nikki, because she's got an interesting story how she's applying 3D. So I'll give you the mic.
Thank you, Michael. Thanks for having me here. My name is Nikki Kaufman, and I started a company called Normal. At Normal, we make custom-fit 3D printed earphones. So they're headphones that actually stay in while you run or while you're walking, and you don't get that ear fatigue that you might get from other headphones on the market. And the way it works is quite simple. You actually download the app, which is available in the iTunes or Android or Google Play Store, or you can come to our store in the middle of Manhattan in Chelsea. And it prompts you to take a photo of each of your ears while holding up a quarter, which we use for scale. And then you customize your normals. You choose the color, the length of the cable, the length of the color of the carrying case, and all these different things. And we build them for you right in the middle of Manhattan. So that store that I was talking about in Chelsea is also our factory. So we deliver your product to you in just about 3 hours. And that's what we do.
So let's go right on to Charlie. Did you guys know the lineup like this, or it just worked out that way? Charlie's got an interesting story because he's behind a service bureau. Can I call it a service bureau? Well, sure. I'll let him explain it. Go ahead, Charlie.
So thank you, Michael, for bringing us all together today. This is exciting stuff to talk about. I am the Director of Business Development at a company called Shapeways. Shapeways is a community and marketplace for 3D printing. The way we work is that someone starts with a 3D file, uploads it to Shapeways, sees if that file is able to be printed, then sees what of 50 different material options that file can be printed in. That ranges from plastic to platinum, porcelain, brass, bronze, steel, full color materials. And then we'll see their cost to print the minimum run for any product and any material, which is just one. They can go ahead and click the print. We'll manufacture on demand, ship it to them anywhere in the world. And or they can also open a shop on Shapeways. And the way that works is that they know their manufacturing costs. They put whatever amount of markup they want to on that product, make it available for sale, then go to sleep. Anyone in the world comes, clicks to buy, and that same process will happen again. We'll handle the payment, manufacture on demand, ship worldwide. We'll then handle customer service after that product is shipped to the customer. And on the 15th of the following month, we'll pay out that designer all of their markup. We'll keep 3.5% just to handle the two transactions. Our own margin comes on the manufacturing side of the different products, different margins for different materials, with always a focus to enable as many people as possible to utilize high definition industrial strength 3D printing.
Great, thank you, Charlie. And we also have somebody who knows in depth the internals or the engineering behind it. And I'd like to introduce. Go ahead.
All right, so thank you, Michael. So my name is Andreas Bastian. I'm a 3D printing research scientist at Autodesk. Autodesk has traditionally, for around 3 decades now, been a design software company, but as of a couple of months ago, we got into hardware as well. So I work on our new Ember 3D printer, which is a photopolymer stereolithography printer. It uses a DLP projector to structure light and cure liquid photopolymer into a solid object. So that lets you resolve very kind of high definition, complex forms. My broader background is in 3D printing research and development, that's a lot of what we're getting ready to dive into at Autodesk. We've announced something called the Spark platform, which is an open and largely open source collection of tools and APIs and algorithms to enable better 3D printing to directly address a lot of the softer side pain points that have been holding the industry back. So the rest of my background is largely on the FDM side of things. So it's the MakerBot flavor of extrusion, thermoplastic printing. I've also done a little bit of bioprinting research at Rice University and I'm very active with the Enable prosthetics community.
So on that note, if we have an acronym up here that you don't understand, just raise your hand and we'll go ahead and explain it. Does everyone know what FDM is before we get started? Yes? No?
I don't.
Fused deposition modeling, also sometimes called FFF, fused filament fabrication. It's basically the hot glue gun technique that Michael had. So, no worries. We have way too many acronyms, and it's acronyms for acronyms. It's terrible.
You think we're in the military? All right, so the next item, we're actually going to get into our myths now, and I'm going to kind of read these off very quickly, but there's a company called 6th that has shown a product called Make VR, and I saw it about a year and a half ago in 2013 at a show in California. And what it does is it allows you to use the STEM system, which allows you to work in 3D space with the Oculus Rift and be able to manipulate. And I'm going to play a little video while if I can play a little video. It kind of shows you how this thing works. And those little pinchers now have been replaced with hands, so it becomes more intuitive. And you have these goggles on, and you're literally watching this thing in space and manipulating it like it's in front of you. So one of the cool things, and I don't think we'll get through the video on it, is that once you complete your object, you can then throw it onto a virtual printer. And then from the virtual printer, it goes to a real-world printer, and then you have a tangible object. So the question is this true, or am I making it up? Just two people? True? Everybody else myth? So, Andreas, you've worked with this or talked with this, and Charlie, you talked to them at CS. So maybe you want to add something to this? Or?
Yeah, I mean it's certainly a truth, and Amir and the guys at 6th Sense, what they're doing is absolutely fantastic, and really I think the biggest barrier of 3D printing just getting much bigger is that 3D modeling, 3D design is very hard. And what Amir and his team have done is create a way that someone can work in 3D space and actually create a printable object. And things, as we see more software improvements like this, I think we'll see 3D printing become even more pervasive throughout the world. So it's a lot of fun in what they've created, but I think most importantly what they've done is really enable people to create in a seemingly very very difficult thing to try to pick up.
And some of you may remember Elon Musk, is it Elon Musk, talked about his process of creating some engines, and I think there was a virtual component in that too, if I remember the video. I don't know if some of you've seen it. So actually it's having an application in the real world events. So it's a little bit more expensive, but this is going to make it more cost effective. So let's go on to the next item, and this is something that Nikki can really shine on, and that is mass customization. It's a growing trend in retail, but it's difficult to scale. Why do you think customers are gravitating towards custom-fit products? And how is Normal using 3D printing to scale the business? So I'm going to just throw that off to Nikki, and she can answer that. And, is this a truth or a myth? Go ahead, Nikki.
Great. Yeah, so it's definitely a truth. It's our ethos at Normal that customers these days are no longer happy with a size, right? Small, medium, and large is no longer right for us, right? We want a product that's specifically built for our body. And it starts, I started with headphones because it was a problem that I had, and because the economics of it made complete sense for the customer as well as from a business perspective. But I do think the idea of customized products for you and your body is much, much bigger than headphones. I'll add that 3D printing absolutely allows us to do this again in an affordable, accessible way. Before Normal, if you wanted to get a custom pair of headphones, it would require a very cumbersome and inaccessible process. You would go to a doctor, an audiologist, they would squirt silicone in your ear, keep your jaw clenched for about 10 minutes, and then literally 6 weeks and $1,000 to $2,000 later, you could get a custom pair. But again, that's not an accessible process for mass, right? So 3D printing allows us to do it in a much more accessible and affordable way. So Normal's costs $199, and it's so simple. Again, you just download the app, take a photo, and then we turn that around in just a couple of hours for you. So absolutely 3D printing allows us to do this and do it at scale.
And I can attest to that. I asked her, well, I'd like to get a pair, and really in about 24 hours, she actually gave it to me personally today, and I fitted them, and they do work. So her technique does work, so it's not just a pie in the sky, it actually is here now, so it's really cool. So let's move on to another item, engineering. I'm assuming that some of you are engineers or planning to go into engineering, but something that some people may not realize, or maybe it's not true, is that this has been around for 30 years. I don't know. Truth or myth? Okay, and why? Andreas?
Yeah, I mean, the technology has been around for a long time, but it's been an extremely inaccessible technology. So it's, what we've seen, the developments that we've seen in the past, probably would say 7 to 9 years, have largely been just a costing down of existing technologies. We have some parts knocking around our office from folks who were in grad school in the early 2000s. Parts printed on the very expensive 3D printers that MIT had at the time, and those parts are virtually indistinguishable from parts produced today. So again, the capabilities of the technology have largely not changed, but the fact that it's costed down has really increased its profile. That's why we're kind of all gathered here today, and we all have some familiarity with the technology. And it's kind of leading to some new use cases. So, as a mechanical design engineer, I have this kind of holy trinity of design, in which I have my CAD software where I design form. I have my 3D printer, and I have my calipers. And so I just go iterate every day through design, iterate on the form, print it out, test it. Usually I'm designing more 3D printers, which conveniently are pretty low load applications that you get with plastic parts. And then test the fit, test the function, and then iterate rapidly through that. In the past, it was very difficult, very expensive to use these machines. Again, they're using much more industrial settings, the size of refrigerators, and just the cost and the kind of cost per cubic centimeter of material and of opportunity to use the material was prohibitively high.
Great. Charlie, Nikki, do you have anything to add to this? Or You know, one of the things that I've noticed is now that more and more people are involved with this, we're seeing more and more innovation. You know, before when it was larger companies that were involved with it, you know, they had it closed for obvious reasons, they want to profit from it. But now that some of that is opened up, we're seeing some unique ways of using. In fact, Autodesk has got their Ember SLA, from what I've heard, because I couldn't afford one. It is excellent. So if you haven't had an opportunity to see it yet, he's got some samples up there.
Yeah, we've got some demo reports for Ember if you guys want. We actually have a lot of small 3D printed things up here.
A lot of fun
after,
stuff.
After the questions at the end, we can all come up and take a look.
Okay. So thank you, Andreas. Okay, so on to the next item, and hopefully if I can set this up right. I don't know if you've heard about it. I don't know, maybe it's not true, but the Chinese are printing homes, houses, apartments. I don't know, is this a truth or a myth? Let's see. Sure enough, this has actually been in the news. I was hoping to get some video, but for some reason, maybe I just didn't have enough time. But this is an example. It was a 5-story apartment building that was created off to the left, one of the manufactured homes in the middle, and then if you can see it, the other panel shows the actual ridging of the printing process. It's literally like a 3D printer with concrete. And you know, it seems a little rough, but you know, it's with some after effect. And one of the things that we're going to talk on, maybe this is an opportunity. If you work with a 3D printer, your quality needs a little bit to be desired. So there's some work that has to be done afterwards, sanding, filling in things. And as you can see, that's clear in this particular picture. Do you guys want to add something to this as far as the finishing process and the manufacture?
I mean, I think first to kind of address the topic of this extremely large format 3D printing. I mean, we've seen some kind of some interesting explorations of the space with these large Chinese projects. In large parts, they have achieved this by building large gantries, basically Cartesian positioning systems out of steel to deposit concretes, and that's viable to a point, but ultimately the technologies that we need to develop and that some architecture programs are beginning to experiment with are these kind of distributed nodal systems for 3D printing. So instead of one head attached to one steel frame, a series of networked, autonomous individual assemblers that share a common virtual coordinate space that is mapped onto your build site. So we need to develop, in order to go larger, we need to develop some more kind of scalable manufacturing paradigms and techniques.
And a little bit more detail on this. That technique was used for a case. Some of these were built outside of it and then shipped and then stacked, or however you want to process it. And the other thing is they use recyclable materials, and the cost seemed to be, at least from their figures, fairly low. So there may be some interest in that. So anybody else want to add to this? Charlie?
It seems like, with these examples that, certainly got lots of press and splashiness around. I mean, they seem to be examples to show that something like this is possible, right? So, okay, it's not a myth, but the reality of actually, getting this involved in our day-to-day world very soon is a bit more of a myth in my mind.
It's easy to make one of something and take a picture.
Exactly.
And get it blogged about a lot. It's
Nikki?
really hard to make 10,000.
Yeah, I think though, while this may have been a 1-off or a 3-off or however many there are that exist, I think that 3D printing, it is possible to create a factory at scale, right? And we've been able to do this with Normal. We have 10 Fortis 250s, which is, it's an FDM machine. You guys mentioned that technique earlier in this conversation. But they don't just come off as finished goods. There is a lot of post-processing that goes into that part to make it something that is a finished good, that's not just a prototype or not just a one-off. So there's a little bit of work that our factory does to make that commensurate with that $200 premium product. So there's some sanding that goes in, we dip it in a vapor smoothing station, and then we give it a coat of soft touch paint. Again, some post-processing that 3D printed part to make it something that you'd want to wear and carry with you at all times.
It's a really, really good point. I mean, with Shapeways and having, we now have 2 factories, one in the Netherlands where we were founded and one in Long Island City, Queens. And I mean, they're 25,000 square feet of space with a bunch of different machines in there. And what we're seeing too in terms of post-processing and other materials, I mean, we can do, rose gold plated brass that looks pretty beautiful. And so in terms of having actually a final object in the consumer's hands, a lot of times people that are familiar with 3D printing just say, okay, yeah, this is rapid prototyping. Well, yes, I mean, you can design and iterate a lot quicker, but now you can have end product goods.
I'd also like to just address one of the kind of very pervasive, very pervasive myths about 3D printing right now is that it's going to change all of manufacturing. And that is entirely incorrect. You know, we're seeing some really fantastic applications. You know, with the kind of small batch, you know, highly customizable things. Largely, a lot of the successful applications are body interfacing. So we're seeing exactly with Nikki's work. You know, there's a lot of variation in human ear canals. There's a lot of companies working with you know, custom orthotics. There's a lot of excitement about the prosthetic space as well. So it's not going to you know, totally replace injection molding, but it will kind of open up some opportunities in these like low volume, high value, especially body interfacing applications.
I hope ours is not low volume.
Yeah, I was just going to say.
We're
high volume.
Everybody has ears. This is true.
This is, yeah.
And actually,
I
Nikki
do
will
believe
have
this is
some-
mass. Yeah.
Nikki will have something to share with you all at the end that I think you'll be excited about. Okay, so I'll move on to the next one. You know, something that has come up, maybe you've seen it already, maybe you have children, or maybe even if you're young enough and still going to school, or maybe old enough and still going to school. 3D printers, I think possibly, maybe, will be as necessary as computers. Myth or truth? Someone's giving me a number, 5 years. Okay, well, let's throw that out. Andreas, why don't you start first on that?
Okay. Yeah, I'd like to, you know, first, you know, bound into the case of education in schools. 3D printers do make a tremendous amount of sense because it's kind of shot glass in a 2 square foot you know, envelope. So there's a tremendous amount of design, fabrication, process. To be learned through using that machine, learning its limitations, learning how to design for those limitations, and learning to design for its strengths. I know, you know, personally, I've been designing for Maddock for several years now. You do deeply ingrain a lot of the capabilities as well as a lot of the limitations. It's important to recognize both of those. More broadly, there's also a lot of hype about the kind of consumer space. There's a lot that needs to happen on both the kind of design, the content side of what gets produced on these machines, and also how the machines themselves behave. Reliability is a huge problem right now. So we are still a very long time off, and perhaps afterwards we could talk about the viability of the consumer market conceptually, but the education market certainly makes a lot of sense.
And in my experience with doing the interviews that I had, some roundtables on education, Europe has actually moved forward with doing a lot of this, and it's integrated within their governmental systems, and they're getting support from that perspective. And the same thing with the Canadians that I heard, they're also starting to integrate this more. And then some of the RepRap groups are really working with some of their school systems. So there's a groundswell, I guess, in the grassroots in our country, but in other areas it's almost a discipline. So I agree with you, 5 years. That's mine. Anybody else? Charlie? Nikki?
Sure. I think just anecdotally I can share that I think the education piece is extremely important for us. You know, I think we only launched it, we launched in August of last year, and we learned that while we only have one store, again, in Manhattan, it's quite small, 50% of our sales come from live, right? So either store or activations where we go and bring a 3D printer and we teach the customer about what's actually going on in that machine. When you educate them about how it's being made and what that process is like, many times they've never seen a 3D printer before. So I think that actually really helps elevate the brand and the product, and that education piece is something that is super, super important. We design the store such that the printers line the perimeter of the store. So you actually walk in and see it, and oftentimes people come in and they say, you know, what do you guys do here? And we say, we make 3D printed earphones, and they'll be standing in front of the machine, and they say, okay, but what's this? And you say, it's a 3D printer, and they'll say, no, but I mean, what is this? And you're like, it's a 3D printer, and it kind of go back and forth a little, and then our team will educate them on what's going on, and it gets them really excited about that, because oftentimes, again, it's new to many folks. So it's an exciting piece for us to share that education around.
You know, Nikki, I didn't mention it earlier, but my wife has also tried to explain this to other people, and they say, well, why don't you just use a copier? So
Right.
They're really not getting the idea behind it. Okay, let's move on to something that I think is kind of intriguing, maybe. How about 3D printing in art and fashion? But, you know, I personally don't want to be wearing plastic, but I don't know, do we have something that allows us to print in synthetics, cotton, hemp? Truth or fiction? Fiction? No. Truth or truth? Truth or myth? There we go. I'm getting mixed up with another topic. Go ahead. What do you think? Another truth? Okay. Who wants to take this?
I can to kind of approach it first from the material side. A lot of us in this room right now are already wearing nylon and polyester PT. These are both materials that we actually print with quite commonly now. A lot of material performance or bulk material performance is derived from structure. Currently, a lot of these kind of early explorations of 3D printing in fashion, we're trying to replicate many of the kind of woven and knit structures that we use with traditional knitting, weaving, loom machines. But this is obviously an extremely small sample. But this is traditionally brittle material, PLA, very commonly used in FDM printers. But you can structure it in such a way that you can achieve a lot of flexibility, the ability to describe compound curvature. There's a lot of potential for structuring matter at this very precise level to derive, novel, in some cases entirely unobserved in nature mechanical properties. So using that, putting that in the aesthetic and design toolkit for highly creative fashion designers is going to be exciting. It's going to be a lot of work to get there.
So Charlie, you've got something to add to this too.
I wasn't able to bring the samples of the dress we did for Dita Von Teese or the stuff we did for the Victoria's Secret Fashion Show, but to your point, I mean, they were structures made out of nylon that, most importantly, were only made for the people that actually wore them, right? So when we think about a body scan and we think about, to Nikki's great point earlier, we don't think about small, medium, large anymore. We think about a piece for you and the way that you want it and the only way that you would want it that we can create it for you. And I think while the stuff for the Victoria's Secret Fashion Show was a little more akin to what you have on the screen, it was still all customized pieces and structures and geometry that couldn't be done in any other way. So it was exciting. That actually came after the project with Dita, but it was pretty amazing to see just in a few months' time how much more forward we had run. Now we see a company called Nervous System in Cambridge, who is taking this one step further, and in terms of actually enabling people to print their own dress for themselves.
And certainly, if you take the material or aside, I think that there is a lot of ways right now with current 3D printing technologies out there that you can inject, fashion, right? So we believe that headphones are a fashion statement. You see those. Also, of course, glasses, right? If you could 3D print a pair of glasses that actually fits, the way that the bridge of your nose and the curvature of your ear. Similarly, footwear and shoes. I think that those are things that we can do right now without any changes in what exists in technology. So.
So let's move on from art into medicine. And this actually, I'm going to play this little video, and this kind of went viral, so I think a lot of people have seen it. I don't know.
I came across Derby a little over 3 months ago now, I think. I had adopted a dog through this rescue group called Peace and Paws. He was born with deformed front legs. And I kept looking at his photo and hearing his story, and I cried literally every time. Finally, I messaged her and I was like, okay, I'll do it. Foster, I'll take care of him. I had to try and help this dog. We decided to get him a cart, which worked quite well, but they limit his mobility in terms of being able to play with other dogs, and it's not really the full motion of running.
For this project, we're using a variety of 3D technologies, and that allows us to get in there and really modify the organic digital models quickly and easily and start to do the sort of designs that Derek wants us to do.
The great thing about using 3D technology in Derby's case is having these images on file on a computer and being able to print them is a lot quicker than having to hand sculpt every single mold and rebuild these braces 5-10 times.
With prosthetics in general, a lot of the designs are going to this running.
Well, I'll go ahead and shut it down. This touched me because I have 2 miniature huskies, and you may have seen my little image. Mine kind of did a photobomb on me in that shot, but so this kind of touched. But more important, I have children as well. And before I hand it over to Andreas, I really want to introduce John, who is part of Enable. So I kind of told you already, this is not a myth. This is really happening. So thank you. And I interviewed him as well, and he's got a great story to tell. But Andreas, why don't you talk more about the technical side and your participation in Enable and what it is?
Yeah, so for anybody who wants to learn more about Enable, so John Scholl is the founder of the Enable community. Will be probably, hopefully, sticking around a little bit after the talk, so definitely feel free to talk to both of us about involvement. So Enable is a global volunteer community that produces low-cost prosthetic hands. Alan's been through a few trade shows, but we make these very low-cost, mechanically driven hands. So it just uses the power of the body, the reflection of the wrist, to close a set of mechanical fingers. So there are a lot of this is kind of a leading-edge case of applying this really flexible fabrication technology that has really short turnaround times. As Nikki mentioned, she's able to produce her earbuds in 3 hours, start to finish. Our devices take usually prints overnight, take another day or so of assembly and fitting. But it's really this kind of experiments, extremely successful experiments in delivering low-cost prosthetics to a largely underserved population. So that's children born with congenital birth defects, something called amniotic band syndrome, which are kind of the chief condition that we work with. And to date, it hasn't really made any sort of economic sense to produce prosthetics for children because it's such a customized fabrication process. It involves so much kind of skilled labor to get that fit proper. By the time that process has concluded, the child has already outgrown the device, largely outgrown the device that was fabricated. So we're kind of finally able to make these devices really rapidly, usually over a weekend. And it's pretty exciting. There's some really interesting implications on kind of physical functionality, enabling grasp, kind of secondary support of objects while they manipulate their dominant hands. But they're, most of the impact that we see, most of the impact that's shared is really a social impact. There's a huge amount of empowerment that the kids and their families feel from using the technology this way. And it's also really turned into this kind of amazing opportunity for identity and self-expression. So kids often really decorate these and request superhero colors, things like that. So it does lead to some interesting tensions in terms of allocating design efforts towards aesthetics or towards functionality. And I see that as one of our kind of bottlenecks or rate limiting steps right now. Is we really do need to get more designers involved in the community because we have a spectacular fabrication network of thousands of volunteers. So.
Yeah, that's a good point. And this is a worldwide endeavor now, and we have volunteers throughout the world, and they're helping people who would never have the opportunity, and that really is a great, warm, and heart-touching story. So again. Yes, totally agree. So you can actually use some of your geekiness to be involved with this, so that's really, really cool. So Nikki or Charlie, do you want to add to this? Okay. So let's move on to another thing, and I think is also very interesting. Actually, before I move on, the other application for this, I was in the news because of it, is the ability to take CT or MRI scans and derive tangible models from that. In the case of this is my wife's skull, and she had a brain tumor. And through this process and working with her surgeons, we're seeing that more and more this is being used for training as well as for pre-procedure, where they're actually able to operate on the materials before actually going in there. So they have some hands-on. And in the training area, they actually can work with a patient then and there instead of an example. So the residents there are finding this very useful. And there's a lot of things in the news on that as well. So to me, this is the truth. So the other area that we're seeing that kind of has a medical side is bioprinting. And this is something, I don't know, is it true? Will.i.am quoted as saying, if you can print a liver or kidney, God dang it, you're going to be able to print a whole freaking person. I don't know, myth or truth?
Leading medical professional.
So yes, it is a truth. In fact, if you read the story, he wants to push laws now so that you're not going to have a person next to you. I think I'm a little bit more worried about cloning than this right now, and the reason for that, and I'm going to kind of dump it over. I had an interview about 2 or 3 months ago with 2 researchers from Rice University, and they really kind of dispelled, in my opinion, the myth that's going around that you can print organs, hearts, livers, kidneys. But the real point is you're able to print like the outer shell, not a full organ in itself with the tissue that needs circulation and the ability to remove waste. And one of the things that they told me is that that's what they're working on at Rice University. And then in our discussion, because we only literally 2 or 3 days ago kind of introduced each other, I found out that he was working with them as well. So I'm going to hand it over to him and let him explain a little bit about that process.
Yeah, so I'm actually another member of the lab too, Anderson Todd, can also speak to this after the panel.
Oh my God.
We're everywhere.
People don't look the same as they do on webcam. But he is one of the ones that I interviewed. So, yeah.
Yeah, so we both did some work in Jordan Miller's lab for microphysiological systems and advanced materials at Rice University. A lot of the work that the lab does focuses on the vascularization challenge in making synthetic tissue. We're really good at growing tissue, well, we're pretty good at growing tissue in sheets. You're able to diffuse nutrients in and diffuse waste products out of thin sheets of cells, because you have a lot of surface area. When you start to make thick blocks of cells, you can do it. You can make some gel, throw some stem cells in, cast it. The cells all die because they aren't able to get oxygen. They're not able to remove waste products. So one of the really kind of really critical techniques that is necessary for advancing tissue engineering and bioprinting is figuring out how to get nutrients to the cells and waste products out of the cells. So there's some really exciting work going on in that field, but it's a really long game. There's still just at the kind of basic biology level, there's still a huge amount that we don't know and don't understand. So it's a very complex space. One of the exciting kind of intermediates to full organ printing is going to be printing small patches. That's going to have pretty huge implications in drug development and discovery. So if you can kind of print out, 400 little postage stamp sized livers, you can test 400, liver toxicity on 400 drugs that afternoon. So that has some potential implications with animal studies, as well as kind of fast tracking to human studies. We're already working with small samples of human tissue.
So I'm going to put Anderson on the spot here. Boy, he's right in front of me and I didn't even recognize him. So what was it, it's been a while now, about 3 or 4 months now. And we talked about developing lungs. So have you made any progress in that?
I don't think I can speak to it too much. It's some pending work that's kind of publication.
He's using them now.
All right, I won't put you on the spot. Okay, let's move on. So, Will.i.am, truth. Okay, another item, and I tried to throw 2 things in at once. Everybody remembers them, well, maybe not, maybe I do, the movie 2001, The Space Odyssey, and then there was another movie called 2010, where we made contact. But one of the things I noticed is that they didn't have a 3D printer, nor were they printing their food. So we have to go back to the Jetsons, which was going around at the same time, to go to their food rack cycle. So, is this the myth or truth now? Can we print our food? And I'm going to let this go to Nikki because she has some food experience. And put her on the spot. Wake up.
I'm awake. Just as a hobby, I went to culinary school, so I'm big into food and stuff like this. I absolutely, this is definitely true, and I absolutely think it's huge in terms of the food industry. And I think, you know, food is very much, you eat it obviously for nourishment, but it's very much an art as much as it is a science. And so I think this is a really exciting, it really has nothing to do with us at Normal, but I'm excited to see what goes on in this space and what restaurants start to 3D print your dessert or appetizer or whatever. I think it can be a really beautiful addition to the culinary arts.
Charlie, you want to add to that?
Yeah, no, I mean, I think it's certainly something that we see and hear more and more of recently, and I think it's something to become more involved in our daily lives at the restaurant or anywhere else.
Yeah, I mean, you know, for a long time I was really kind of frustrated with the hype and excitement about 3D printing, because to date, the main way that's manifested is you take something wonderful and you put it in a blender and you make a paste out of it and you squirt it out of it. Which is, food is about like the lovely interactions between like different textures and flavors and like, composure. And so that seems to stand in the face of everything that's beautiful about it. However, recently, after giving a lecture at NYU ITP last fall to a bunch of fashion design students, somebody was lecturing about, the implications kind of mesostructure, microstructure, and controllable mechanical properties. Was talking about fluidic and pneumatic computation. At the end, somebody asked, so has anybody applied this to food yet? And thinking through it a little bit more, I mean, food is fundamentally a cellular and often fluidic structure because we're eating biological tissue. And so there are some really interesting kind of structural analogs there. So maybe one day, very far in the future, you can eat a programmed jelly donut that is performing jelly computation dynamically, reacting, changing its structure as you eat it. But we're not there yet.
Okay, actually, I'm going to bring some truth into this. When I was at CES, it's a company called XYZ Printing. I don't know if that's the actual, the parent company. But are they from China or Taiwan? I can't remember. You don't actually say that in front of a Taiwanese. But they have, and I think they mentioned it's going to be $600. They're going to have a food printer, and they were actually handing out cookies, and they actually tasted fairly good. So yes, you're not going to get very complicated culinary foods out of this thing, but yeah, you can
consuming
print
the novelty of 3D.
and wow.
So for the near future.
Okay. All right, so I was a little bit surprised that my panelists here had no idea what I was talking about. Who in here has heard of Portlandia, please? Okay. All right, there's some hands. Thank you. Gosh, I felt like, man, am I old or something? Do I just have a different type of thinking? Well, I'm on the West Coast, so maybe we kind of like Portland. And obviously, they make fun of the Portlandian, and it's an interesting humor comic type show. But one of the, actually I think they ran 1 or 2 episodes where the mayor decided they needed a 3D printer. And somebody asked, well, what do you need a 3D printer for and how are you paying? Well, we'll have the budget because we need one. Why? Because everybody has one. And what did he do with it? He created a likeness of himself. So I'm going to use that to kind of segue into, we have the opportunity now to be able to use IP or intellectual property of TV shows, movies, games, comics, graphic novels, and even our own likenesses. And is that going to be an issue in the future? And I'm going to hand that over to Charlie because working at Shapeways, and he's got a little story here that I hope he can tell us of how IP is playing in all this. And, are we moving forward with having the ability to custom make IP items? Go ahead, Charlie.
Yeah, and the answer is not only that we're moving forward, it's that we've already done it. And I think just taking a step back, earlier we were talking about the fact that we don't really believe that this is going to completely, make us all forget about mass manufacturing. We understand the benefits, we understand why it came. We think back to before the Industrial Revolution, and we know that then everything was custom too, right? Everything was made by hand, everything was made to spec. So what we think now is we understand those benefits of mass manufacturing, but we also understand that the connection with our customer is lost, becomes negligible. And as a result, their loyalty has to be bought. So this 3D printing and mass customization, what it enables a brand to do with its IP is actually reach out to its most fanatical customers and ask them what they want to see and what's in their head that couldn't be done before. We spoke to many different brands about this idea, and a lot of them were actually incredibly excited about it, but no one really went completely over the finish line. Something kind of nerves set in, and all of a sudden, the deal was lost. But that wasn't the case with Hasbro. Hasbro wanted to do just that, and what they did was they said, okay, let's do this. Let's put some kind of gates around this, but let's say to our fans, tell us what you think My Little Pony should look like. Your favorite My Little Pony character in a different pose or something else. Tell us what you think it should look like. And if it successfully went through that moderation process, that person would be able to act in our marketplace just like anyone else can in terms of uploading the file, see what it costs them to print it, put their markup on it, and then make it available for sale. So what we enabled was basically a license on behalf of a community of 500,000 people to try to get closer to the Hasbro brand by doing this. And it was incredible to see the response. And I really think it's something now that's in brands' hands to help us push forward. Not only do I love normal earphones, I mean, just the idea of what Nikki has created is so important and awesome, in that those headphones aren't just a different color or a different size. Those are yours. And no one else has anything like them because they are unique to you, right? And with IP, we have the ability to actually let people in on this process. Certainly since Hasbro, there have been now a lot of the same or different companies that have said, okay, how do we get involved with this, right? How do we get closer to our customers? Because I think that's what we really are able to create, right? Leveraging that minimum run of one. Yeah.
Thank you, Charlie. Okay, well, we're about done with our truth or myths, and we're going to kind of open it up now and kind of talk about what are the challenges with 3D printing. So I'm going to ask each of my panelists to kind of talk about that. And then we're going to open it up for questions and answers. I'm told that we are the last session, so I don't know how quickly they're going to push us out of here. Hopefully not too quickly, and then we can get together and kind of talk about some things. So each of you, I'll start with Andreas. Go ahead, please.
I mean, there are a lot of really interesting, very technical challenges in 3D printing. I think one of the more interesting ones that gets a lot less traction is every 3D printer is really a manifestation of the question of what to make. It's an opportunity to make something. It's a question, and that question hasn't really been answered terribly well yet, largely. We're starting to see, I think, some of the first kind of real applications. So a lot of these body interfacing things, particularly the prosthetics, are very, very interesting cases, very interesting real use cases for 3D printers. But one of the big challenges is there are nowhere near as many kind of designed objects for 3D printing. I mean, when we look around at everything around us, everything in our environment has been very carefully, intentionally labored over for hundreds of hours. I mean, just to kind of ballpark the design costs, the development cost behind geometry, it was about 600 to 800 hours of design, testing, and development behind just this little, very simple geometry. So getting truly valuable, interesting, unique objects, there still aren't that many of them out there. If you look at everything that's on the theaters, everything's kind of freely available to download. It's often, in terms of kind of design investment, very cheap stuff. Kind of really quick one-offs done maybe in a couple hours. So I think one of the really interesting opportunities and challenges here is there's just not a lot of good, interesting, meaningful things to print. So I'm really excited about kind of increasing access to design tools and getting more people designing to make things.
Charlie?
Yeah, like I mentioned earlier, I mean, just completely in line with that is, the biggest barrier to 3D printing becoming massive is that 3D design is incredibly difficult. So we're seeing great advances in software and enabling people, perhaps without, engineering skill and artistic skill to actually get involved. You know, when we started with 6 Sense there and seeing Make VR, and then, you know, we're seeing that possibility evolve. And so what I'm most excited about is you know, the idea of everyone being able to actually create. So if we think about those interesting objects that need to be created, I mean, we see it at Shapeways with the designers, with the makers that are uploading over 150,000 unique items every month, right? So, you know, the challenge is to be able to get everyone everywhere to be able to do that. And I think, you know, with these, certainly with the advances in software, that'll help us get there.
Yeah, and I think for us, you know, I mentioned that it takes 3 hours, or in Michael's case, you know, if you're on the opposite side of the country, we'll ship it overnight to you. So in that case, it's 24 hours. You know, I'd love us to get to a point where it's under an hour, right? You walk into the store, or you walk into a kiosk, or the mobile normal truck, or whatever it might be, you place your order, and then you watch it printed, and you walk out with it right then and there. Right now, there is limitations by what the 3D printers can do. So the actual print time itself is an hour. It's not getting any lower, it's an hour. If you print 1 at a time, it's an hour. If you print 5 at a time, it's 5 hours. So, and then there's that post-processing. That's the sanding and the smoothing and the soft touch and the drying time and whatever. So it ends up being about 3 hours. But I'd love to get to a point where the software is improved, the machines are improved, so you don't have to sand it, and the print time is reduced, and we can do something in under 30 minutes. So that's where I see, hopefully we can go in the future.
You guys were great. We did it in 1 hour. Okay, so I'm opening it now for questions and answers. Maybe you can have answers, we can have questions. All right, here we go. Please.
What extent is 3D scanning help solve that problem of the creation of new content? And at one point, I got really excited about the thought of that, because I was talking to Andreas yesterday, and there's still physics to that. Even if we design that helicopter with a hands virtual reality, is it going to fly? Did I line up those wings just right? Look cool in the picture, but were they just right? So where between the kind of promise and the disappointment should that be a precise hyperlink?
Okay, you mentioned it yesterday. I'll take a stab at it. One of the things is that we have a lot of things converging at the same time. Not only do we have the ability to create tangible products, but the mathematics and the computational power we have in order to simulate has advanced as well. So if you keep that in mind, that we can take these structures and stress them. There's programs like SolidWorks, Autodesk Inventor, who have this capability, so you can now take these materials and mimic their properties and do this in the computer. Now, is it completely accurate? No. It's like, you know, people complaining about analog audio versus digital audio. You quantize things, so you're still going to have a level that may be unknown, and that's why you still have to create tangible objects and test them. But it takes us much closer to that. And as I mentioned earlier with Elon Musk, he is probably one of the biggest promoters in using this type of ability, where you're doing analysis first on the computer and then creating components. You reduce the amount of iterations, the time it takes to create a final product. And I'll hand it over to you.
Yeah, I would characterize, you know, there's a lot of excitement about kind of capturing geometry. And I think currently what mesh data, what scan data is more of a tool in a broader design process. It's pretty, you know, what design information is a highly structured, in a lot of ways you can also make analogs to object-oriented, you know, data structure. That, you know, what facilitates, and actually Charlie, I think, I can speak to this with their work with Shape.js and Shapeways, is in order to kind of leverage the capabilities of these very small tweaks and customizations between geometry, you have to have a geometry descriptive format, a CAD format that supports that. And mesh data is very information poor. It's non-configurable. It's a static capture instead of what I like to think of kind of parametric design information is it's a kind of a probability fields of potential geometry, you know, all the different combinations of your parameters. And so the mesh scan data is one crystallization of that parameter space, but it's a fixed thing. So it's useful if you're interfacing with that geometry, but it's just a static tool in the process.
Yeah, I mean, in terms of scanning and the companies we've worked with, there are a bunch of different, you know, kind of consumer plays out there. We've seen great advances, I would say, in the last like year and a half. But you know, it's still, there isn't the turnkey solution just yet.
By the way, I specialize in 3D scanning, so maybe we can talk later. Do you have a question? I noticed that we have a mic there. I'm wondering if it works.
Great.
Yeah. Go ahead,
Very
please.
well. I have a really obvious question, and maybe because it's so obvious, there's no reason to address it. I like the My Little Pony story, and I think there's a lot of potential there in the short term. But what happens when 3D printers become like laser printers, and everybody's got one? Hasbro loses control of its brand at that point, right? There'll be bootleg CAD 3D, My Little Ponies out there that you can download and print your own.
Right.
And they won't all be, G-rated either.
I'd like to add that I've got an actual personal story. I have some intellectual property. I have a product that extends or improves the performance of what they call a structured light sensor or scanner, and it gives you about 34%. I had an individual who wanted one of my betas very quickly and decided not only to use it, but to reproduce it and then put it up on Thingiverse. And how do you determine how many sales you lose from that? But yes, I have some personal experience, and you can ask my wife. I was pretty livid at this, and it was funny. I went and met him at Real. Actually, didn't meet him. He kind of ran away from me, so I guess he knew that I was a little upset with him. But that's a good point.
I understand that you personally had a difficulty with it. Do you personally have a solution?
Well, one of the things is you push to get your IP protected and through patents and trademarks and that, which is what I'm moving forward with now. John?
I want to point out that Marvel comics and DC comics did in fact survive the era of Xerox.
They did, and so did books. When Xerox machines first came out, the book publishers fought tooth and nail to have them banned, because they thought it would be the end of books because of all the bootlegging.
Well, I'd like to make comments. That there's a lot of this kind of vague fears about distributed manufacturing and people making all sorts of things. But we have the tools. We could make pipe bombs every day. We could make our own garments with sewing machines. We could make bikes. We know very select few people do that because it's a pain in the ass to make stuff.
Right,
Yeah,
that's
and
true.
on top of that,
But what's not a pain in the ass today? Bootlegging music. And
So
becomes
so
that
obviously
easy.
there's a lot that's going to have to adapt to sustain these changes in our fabrication capabilities, and they're all going to. It's not going to be it's going to be a highly asynchronous process.
Sure.
And there are probably going to be some pain points, but I don't think there's going to be a whole lot of massive disruption.
Okay.
I couldn't agree more, right? I mean,
We've got a question over here. Let me go ahead and.
I wanted to ask about the future of 3D output in general. I mean, is the next few years faster, more precise, more materials 3D printers, or are there key technologies like laser, epoxy?
Yeah, we didn't really get into a lot of different technologies, but yes, there's a lot of things coming that are going to advance it. Some of the things we're talking about, IP and things like that, are going to play even more of an important role. You talked about the copier producing books. Well, you remember the old copiers. Would you rather have a book or have a copier print something out that normally costs you 5 to 10 times more, and you've got smears, you've got marks on it. It was nothing like the book that you could have purchased that was done professionally. So that's where we're at with 3D printing, but what are we going to be like in 10 years? Because we can get that quality in 3D or 2D printing that we didn't have 10 years ago.
Right, and in terms of that, everyone having a 3D printer in their home, I am frequently asked, like, well, Charlie, with more consumer printers, be it MakerBots, Formlabs, Cubes, whatever, pick your whatever you like. But the idea is that I don't. First off, we love it. We love the fact that it's actually getting the idea of 3D printing in everyone's mind. I think it's a great point, Michael, that people, if they're able to now find something on Thingiverse and print it at their house, okay. But at the same time, too, we're never going to be able to get around people trying to break some sort of rule somehow, right? I mean, if you want to buy a nice fancy watch and you're in New York City, you can go to any beautiful store on Madison Avenue or Fifth Avenue, but you know what? you could also go down to the World Trade Center and there's a guy on the side of the street who's probably going to sell you one for $10, right?
It won't work a week.
Exactly, right? So, I mean, but the point is that what we see now is that people are actually creating, and these are people that they don't want to fight against the brands. They want to be closer to those brands, right? And it only makes sense for those brands to, in my mind, bring them into the fold, to engage them. So yeah, I think there will be people that will always be trying to break any sort of rule that's out there, but I don't foresee something coming in the future where everyone's printing their own bad My Little Pony that you shouldn't show to anyone. I mean, bias aside, I think it's really important, that we saw a massive IP holder actually start to open up their hands a little bit.
Okay. Well, somebody just came up and told me we're finished, so I do want to give Nikki the last word, and then are we done in this room, or?
You have 10 extra minutes, but this is the official cutoff time.
Okay, so we have 10 minutes after this. Okay, so I'm going to have Nikki give the last words here, and then maybe we can congregate a little bit, and then I guess we're out of here. So go ahead.
Thank you. I just wanted to mention that normals cost $199 normally, but for the next 48 hours, we're doing a special deal for all South by Southwest attendees. So they're $100 for the next 48 hours if you use the code SXSW15. So South by Southwest 15 at checkout, $100 normals. Thank you, guys.
Yeah.
And there was a contest. You gave me that sheet of paper, so whoever gets up here first, I've got 2 items to give away, and I'm welcome to take that, and you're also up here to take a look at our stuff. So thank you very much, everybody. I appreciate you coming.